Hello, my name's Ian Marcroft and I work here at Qumulo as a systems engineer. What I want to do today is do a walkthrough of our dashboard. Now, if you haven't seen our dashboard in a while, because here at Qumulo we run what's called an agile software development, what we do is we release code every 2 weeks. So new code. In that code we tend to have performance improvements as well as new software features. So if you haven't seen it for a while, then this has probably changed a lot because we've had a lot of widgets added into our dashboard. So here we go. This is our dashboard itself, and in here we get a great breakdown of what that file system consumption looks like around metadata and snapshots, etc. How many nodes are in my cluster and what that file count looks like within this environment. So we've got some cluster activity here, and something that's fairly new in here is showing you the latency of the file system at any particular point in time. What we're looking at here is what's in this window down here. So if I increase or decrease that, it gives us more or less metrics that we want to look at within the file system itself. As we scroll down, also some new widgets down here are my read distribution and write distribution over the last 24 hours. And you can see how that's broken out and what the current throughput is right now in the file system. So current throughput, you may ask, so how are we actually doing that? So I can tell you what we're not doing, and we're not tree walking. So what we do is we do what's called aggregated metadata tagging. So we tag every single file and directory in the file system. As changes happen, we mark those changes and push them up into a structure inside the file system that holds all this metadata information. And then what we do is we sample that metadata information about every 10 to 15 seconds. So that's why you can see it changing on the screen as you can. So you can see all that. That's why we call it real time. So we can see exactly what's happening with capacity consumption and throughput and IOP information and latency information in the file system right now. So the cluster that we're reviewing here is our cluster, what we do a lot of our file system testing on. So as I say, we test code every 2 weeks. So we run 500,000 automated tests every day on our code, and this is the cluster that we test it on. And that's a continuous cycle as we release code every 2 weeks. So when we say we release code every 2 weeks, a lot of customers get scared that they have to upgrade every 2 weeks. You don't. We also offer you a quarterly upgrade that you can do, but the upgrades take 4 minutes end to end with very little disruption, so most customers can do it in their dinner break if they want to. And because we upgrade all the time, we're really good at it. We're really good at it, we're really fast at it, and there are very little problems because of all this testing that we do. So scrolling down, we can see client activity. So that's the breakdown of what the clients are, whether they're NFS and SMB, how many of them are there, and how are they distributed across our cluster. So we can see here we've got quite a lot of, probably double the clients on these nodes and not so much on these. So we may want to look at redistributing these so we actually load balance them across all the nodes. And we can look at the most active clients at the moment from this dash as well. It's giving you the IP address and what throughput numbers and IOP numbers they're pulling this particular client. And we can also look at capacity trending as well. So what my top directory changes are, and then what a summary of my increase or decrease within my file system looks like. And with each of these we've got little links to, so we can jump into the GUI, into different sections to actually get more detail on each of these pieces of information. So what I'm going to do is I'm going to jump into my analytics section here, and in particular what we call our integrated analytics. This gives you a breakdown of the entire directory structure in my file system. As you can see from the legend here, I've got the choice of looking at different sampling information on throughput, IOPS or metadata. So I may want to just look at metadata information, and you can see that the graph below us changes as we select and deselect that information, mapping it out for us. If I click on the root of my file system, this tells me exactly how many files and directories are in my entire directory structure. What are my top activity clients? Which clients are hitting this file system the hardest? And what directories are they hitting? We can also, as I say, see a breakdown of each of our directories, and I can click on any one of these and get great access to what's happening in that directory right here. So that tells me what client it is that's pushing those performance numbers. So what I'm going to do now is jump into my capacity information, so I can look at Capacity Explorer. This shows me the breakdown of what's in each directory. I can hover over and it will give me some meaningful information around permissions and sizes. I can drill into it and see what's in each directory itself. I can come back to the root, so I can decide which ones I want to jump into and jump back from in my Explorer. And then I can also jump into trending, capacity trends. So capacity trends is very powerful. So it's got quite a flat graph here of capacity history because of the type of work that this cluster is doing. It gives me a breakdown of how the growth in my trends look like over the last 72 hours, 30 days, or even all the way back to a year. So I can click on that and see how that's changed over the last year. So not a huge amount, it's fairly flat, as I said, because of the type of work that we're doing on this cluster. But something that's really powerful that this gives us is the ability to see what's happening on the cluster in each hour segment. What data is added to the cluster, what data is taken away. Now, it doesn't matter how big or small my cluster is. I can have a 5 petabyte cluster, or I can have a 500 terabyte cluster. It doesn't matter to this, because I'm not tree walking the file system. This data is available to me real time. I can see what data has been added into my cluster and what data has been taken away in my cluster. So if I click on that particular box there on that particular date, it will tell me exactly what data has been added in that time frame and what data has been taken away in that time frame and what directories they were taken from. Similarly here, what data has been taken away and what data has been added in that 1 hour window on that particular date. Really powerful for system administrators to have that at their fingertips. You ask them how you'd normally do that on a day-to-day basis, tends to involve phones or emails to different groups of people who they think may well be the culprits of dumping large amounts of data, not knowing where it is. Data visibility. So I could jump into our other activity areas here, so I can look at my throughput hotspots. What are my top hitting hotspots at the moment? If I hover over that particular section there, it tells me that 69% or 164 megabytes per second is happening on that particular directory. So that's the hotspot of that directory itself. I can also look at breakdown by client. I mean, these are really powerful. So I can see what client is pulling what throughput and IOP information anywhere in my file system. So these are a list of all my clients, IP address, DNS name, and I can see what they're doing at this particular point in time. And you'll see that that's changing real time. Every 10 to 15 seconds we're sampling that database. How is that metadata information changing? How the performance metrics changing? Display it in here. I can drill down and I can see exactly what files they're actually touching at this particular point in time and what numbers they're pushing. Same again for this client here. What files are they touching and what are the throughput and metadata information they're pulling on these particular file systems, the files and directories. So as I say, really, really powerful. I can look at it the other way around as well. If I know the path, I don't know the client, I can click on the path here and then expand, and it will show me which clients are accessing those particular files or directories. Really powerful real-time analytics, great data visibility. So now I'm going to jump into the sharing section here. We can see quotas. Once again, quotas, they jump into this, our real-time analytic, our real-time metadata aggregation. So if I set a quota on a directory, it's enforced immediately. I don't have to do a tree walk of this. So if I've got a rogue user that's writing a lot of data into a particular area, I can't get access to them to tell them to stop doing it because they might be filling the file system up. I can come into here, create a directory quota, enforce it, and it will stop them writing. Great control. Our GUI here is designed so that you're 2 clicks away from what you want to do. So we're not interested in sending you down a rabbit hole of where you think something might be, where you want to view or configure it. So if I want to create an NFS export, I come into NFS exports and I click on create. Fill in the relevant information, set host access rules, save. That's your export complete. SMB shares are the same. Come into SMB sharing, click share, create a share, fill in my relevant information here. Do I want to set access-based enumeration? Do I want to require SMB3 encryption? And what sort of create rules do I want to set for my files and directories? This is if I'm using a mixed mode environment and I want to set some sort of POSIX permissions within here. And then I set my share level permissions, allow and deny, create my share. So that's sharing. So when I want to look at now my cluster information, I can now go into look at my cluster overview. This shows me that I've got my protection set. I'm protected against 2 drives or 1 node. We use software erasure coding. We typically rebuild drives within an hour, once again, which hooks into that. No need to do a tree walk. We've got all this metadata aggregation, so we can rebuild drives really quickly. I can restart or shut down my cluster from within here, and I can look at, this is a 10 node cluster, and I can drill into each of those nodes if I want to, and it will show me if I've got hard drive failures from within here, and I can switch on and off the UID light. Jump into snapshotting. So within snapshotting, I can take a snapshot now if I want to, or I can set a policy whereby I decide, which directories I want to snapshot and what that schedule would look like. Is it going to be hourly, weekly, or monthly schedule? And when do I want to delete these snapshots? Do I want to set an automatic deletion policy after a certain amount of time? These snapshots all hook into VSS, which means that as an end user, I can look in previous versions, I can see these snapshots, and I can recover my own data if I've accidentally deleted it. Replication, we have inbuilt replication. Continuous replication, it's an asynchronous replication. We do a baseline transfer and then we do snapshot based updates. It's continuous. As we start to add data into a source directory, it will take a snapshot and it will send those delta changes over to the destination. It's a continuous method that's running. We don't do a schedule on a certain time of the day. If I want to create a relationship, source, destination, and I could also set what's called a blackout window here. So if there is a particular point of time of the day where perhaps you're really busy and you don't want to have a replication running, you can set a blackout window. What else is useful in here? Auditing. So auditing is reasonably new into the product. It's been in there a couple of months now. I can output my syslogs to maybe a Splunk or a Varonis or a Stealth Bits environment or whatever auditing environment you've got up and running. We can just set the IP addresses within here or a URL, and it will push all the auditing information out to your environment. I can rename the cluster. Adding nodes is really simple. You don't have to set up PS time for someone to come in and actually add information or add nodes to be able to scale this environment. You can do it yourself. You put a node into the rack, plug it in, plug the network connections in, and it will automatically discover the node. We use IP version 6 link local discovery to find the nodes, and then you can, within here, once you do an add node, it will come up in the list here of nodes available. You click on add. That's as difficult as it is. Role-based management, that's also something that's fairly new in the product. So we can control exactly who has access to do what within the cluster, who can reboot it, who can upgrade it, who can set shares. Do we just want users that can just view things? We can set that up within our role-based access control. And obviously we can hook into Active Directory and LDAP from within here. We can automate everything within here as well through our API, as you'd expect. You can automate the build. You can also do things like hook into media asset managers via APIs. So within here, we just allow you to have a look at what particular API call you might want to look at. You may want to try it, and we'll give you JSON output scripts to see what that output looks like and what the actual call is to the API environment. So all this in here. As I say, you can come in here and look at what API calls you might want to look at. So we can get our SMB sessions, look at that. What's our SMB server sessions set up, and you can see within here. Snapshots, if I might want to create a snapshot, or I may want to get information about my snapshot policies. I can have a look at it here, and it will show me all the relevant information in here that I need as far as JSON outputs and stuff are concerned. So everything's written into the API first, so we don't have anything that you can't do on an API call. We have a lot of customers that say that even build the environment out using things like, you know, Puppet and stuff like that to automate the build of this and to build it in the cloud as well. Because don't forget, you can get Qumulo running in the cloud as well as on premise in a hybrid mode. And lastly, I'll just look into the support here. So our Qumulo Care section here. So cloud-based monitoring, we pull anonymized analytical data off all our clusters, which allows us to crunch that window down to time to resolution on a support call. Because we've got a ton of analytical information, we don't need to have level 1 guys when you report a problem that come in and will actually ask you things like, can we have some logs, can we have some information off you? We have all the relevant information we need to try and troubleshoot your problem. We even do pull analytics off every individual hard drive out there to check the latency of those drives to make sure that they're not having a high latency, which will have a detrimental effect on the entire cluster. And then also remote support. We can enable remote support for you if you want to. We can come in via VPN and help you troubleshoot on your cluster. And lastly, software upgrades. I mentioned earlier that we run an agile software method of deploying code. We release every 2 weeks. You can upgrade your code from within here. As I say, end to end, it takes 4 minutes to upgrade the entire cluster. So really fast way of getting the code updated. So as I say, that's a run through of Qumulo version 3.05 of the GUI. I'm Ian Marcroft. Thanks very much for watching.